Hey everyone, welcome back to today's lecture. Today we are going to look at the advanced concepts and commands in Git. We are going to look at what is branching terminology is. We are going to look at different commands such as what is git stash is. We are going to look at what is reflog is. We are going to look at what is cherry pick commit is, how you could implement those. We are going to look at how we could resolve git conflicts in your code. We are also going to look at how you could compare difference between two commits. With this, let's get started. So in our previous lecture, we know that what does branch means. So if someone asks you what does branch means, you don't have to tell them that is a barn of the tree. You know that branches is a pointer to a specific commit. So in visualization, we could look at this like here is our main branch of code. Here we have commits, and here is our head, and we have main branch, and we create another branch which is known as suppose feature or something hotfix or like stage 1 or UAT. These are the terminology used in branching. These terminology have specific meaning, and today we are going to look at what does this specific terminology means. Also, you know that branching does not is memory efficient because it does not cost any space. So there's always a thumb rule: branch early and branch often. So if you are working on your code, you always need to branch it out, and because you don't want to mess the main line of the code. So there's always saying branch early, branch often. Cool. We know that what does branching mean. Now we are going to look at what other terminology used. Now it's time to learn about branching terminology used in Git. So the first terminology is used as main branch or master branch. Basically, decade earlier, GitHub changed their main line of code branch from master to main branch because that master branch was uh, term to avoid from slavery references. So here you could see that GitHub replaced their master branch with alternative term that is main branch to avoid slave reference, and so should MasterCard should also change their name, might be to main card to avoid slave reference, but it's particular meme. So basically main branch, what it is considered to be stable branch. So if you are working in software companies, they have their main branch which is considered to be stable, where all the connection pipeline is connected to it and it's production ready. So if you are doing some code on, so you shouldn't be on the main branch, you should create some other branch and should create a pull request to, if you want to contribute to code. So basically in decade ago it was named as master, we now name it as main branch. Cool, now we know what is master branch is. Now let us look at development branch. So what happened is, so here is our main line of code or production ready code, here it is, and here is our head which is our master branch. And what do we do is we create a PR. Suppose we create a pull request, we create our branch, and we create a merge request to it. We create a feature one branch. So it have implemented some feature, and we are now pushing it to the master branch or main branch. So the issue here is the amount of confidence. Okay, so we know that this code is good, but should we directly push it to the production ready code? And if that happen and suppose there is some bug, it will directly mess up the production ready code, and it will lead to like the thing would happen is like the user who is using your software would have some difficulty because of this bugging code that have been directly pushed to the master branch. So in order to avoid this, we have development branch. What development branch is, it follows its commit. It has same commits of master branch, but it is commit ahead than master branch. Basically, all the feature changes are first pushed to development branch. All the changes are first. This is our development branch, and here's our master branch. All our changes, like we implemented some changes, instead of making a pull request directly to master branch, we create pull request to development branch. It have separate pipeline, separate environment where we could test our code on, instead directly pushing out to the production ready code environment. So it's better for development. So now tester can test this development branch and he could check out, okay, the whole environment is working fine. Now we have more confidence directly pushing to the directly, and once the tester gives the confirmation that the code is working, now we have more confidence that we could directly push it to the master branch instead of directly pushing the feature branch into the master. We have lot of separate environment for this testing. So we have, first is user acceptance testing. This is final testing in which we check out whole code. Then we have a QA branch, which is quality assurance testing, in which we check, okay, this feature is working. Now we could have more confidence in pushing out to the UAT. Then we push out to the master branch. In this way, we have more confidence directly pushing to the code instead of directly pushing your code into the master branch. You first push your code into QA, then into user acceptance testing, then to the master. In this way, we have more confidence directly pushing on to the master branch, and in this way, we could also find out the bugs. What are the bugs out? We could squash them out. So now let us look at the definition of development branch. A branch where the main development task place and the feature are integrated into it, and then they are directly merged onto that. So any features that are being implemented are first pushed on to the QA branch in software development life cycle. So it's on to the QA environment first, that is QA branch, and if it's working, the tester check those feature, and okay, then the tester passed those. Okay, if it's working, it doesn't have any bugs, then we push it to the UAT. Then the tester check once again, and then to the master branch. In this way, we don't have most of the bugs. They are sorted down directly onto the UAT and QA. Now we have got the idea what our development branch are. Now let us look on to the what does feature branch means. Feature branch means is basically branches that have, so we are implementing some features, so we directly can't push to the main branch. We create a branch from the main branch, and then we create some feature. Suppose we added some feature 1, we implemented some feature, we push it into QA branch, then to UAT, then it's finally tested, and if no bugs found out, it's pushed down to main branch. Now we have got idea what is feature branch is. Similarly, we have patch branch, we have hotfix branch, just to fix out those errors. So now let us look at the definition of feature branches. Branches that are created for developing new features. Similarly, for hotfix, they are created, or patches, they are created for fixing out those bugs and errors in the code. They typically branch off from the development branch and are merged into the once the feature is completed and testing. So the naming convention is like feature and which feature you are implementing. So the other devs could know, okay, this branch implements this feature. Let us look at what is stash, what is the purpose of stash, and the Git implementation of stash. So suppose here we are coding in our feature branch, and we are fetched this branch from the main repository, which is on GitHub. Here we have fetched this branch from the GitHub, and suppose Here we are working on this branch. We have commit 1, commit 2, commit n, and suppose here we are working in this head, and now some changes have been applied to that branch. Suppose it's feature branch and some changes have been applied by dev2 who is working here. He pushed that code. Now we have also written some part of a code. Suppose the dev2 and dev1 are working on the same line of a code, and dev2 pushed that changes, and suppose dev1 is also working on that line of a code and he wants to pull that code. And what will happen is, that is known as code conflict will occur. The Git will tell that there is a conflict because in the changes requested, this new line is coming that is going to override your code. Either you stash out or commit the code out. So we can't commit the code out because the code might be incomplete or you are still working on. So what do we here? Is we git stash. So basically it temporarily saves the code in the working directory, and whenever we pull the code, we could reapply those changes by using git apply, and those changes would be applied to the above onto the commit that we have pulled. So basically git stash is used when you want to pull the latest changes, or git stash is used when we want to check out from one branch to another branch without losing our work. So here you could see this is a meme. What does git stash purpose it? It's you let me push without merge conflicts and let him check out from one branch to another. And you could imagine how important it is. Let us look at the definition of git stash. Git stash is a temporary way to save changes that we don't want to commit yet. It's used to pull changes from another branch, or you want to switch branches. The git stash allows you to save uncommitted changes and clean your working directory. You can later apply your changes back to your working directory with git stash apply or git stash pop once it's have been applied and you want to remove the changes. So here you could see that you stash your code, you then apply the git stash apply, but those changes will be still remaining on your directory. You want to remove it by calling git stash pop. If you don't call the pop, it will still save there, and you need to call the pop to save your memory reference. So now we have totally got what is git stash is. Now let us look at the coding implementation, how in git commands it would look like. Now let us look at how does git stash look onto the coding environment. Now let us see how does git stash look in console. So suppose here is our readme.md file. We added, this is next line, we added new line, and we staged those changes but not committed yet. And now we branch out to check out and go to the main branch. Suppose there is new feature implemented onto the main branch, we need to check those out. So git switch to main, and here, master branch, and here you could see that your local changes to the following file would be checked out. So these changes would be gone if you checked out. So please commit your changes or stash them. So we are going to stash them, and then we are going to git switch to the master branch, and here we could see those changes, and okay, we got the idea what are the changes have been implemented. Now we go back to our switch our branch to the main feature branch, and to get our changes we just need to call git stash apply, and we will get our file. With this we have looked at how does git stash work. Now let us look at the one of the most important tool out there, that is git reflog. So basically, Git reflog is a tool that track and changes to the tip of the branches. It have all the history of the changes that have been done. It's not like Git log. It contain more information than Git log. So suppose Git log only shows you the commit history, whereas the Git reflog shows you whole thing that have been done to the code. So it shows your merge request, it shows your pull request, it shows your checkout, it shows your commits, it shows from the branch to the whole tip of the code. Now let us see how it looks in the command log. So this is our code and we want to look at what changes have been done from the tip of the code, tip of the branch to till now. So if we type git reflog, we could get whole thing that currently your head on the feature branch. If it is, we see that it's checked out from master to feature. Yes, it was because we were checking out the git stash command, and there we were changing those branches. So here we could see that what are the changes made. If we want to, we know what does reflog do. So one of the most important use case is getting the commit right back to us. So suppose we set hard a commit. Suppose we call the flag hard, and from the head, from our head we just remove the previous one, that is first commit that in our branch, and we removed that code. Now if we want to get back to that code, how we could do that? So we call get reflog what has been done. So we are now looking at what changes have been done. So here we see that reset have been called and that changes have been done. So here we could see the commit that have been done. So we could create a new command to recover those commit by creating a new branch. So we create git checkout the branch, let's say recovered branch, and the hash. And if we go on to the recovered branch that we are on, and here we have those commit that was being deleted. Now we have successfully retrieved it. You could see how powerful reflog is. If you suppose deleted any commits, you want to get it back, or you deleted some code, you could get back those code by using reflog and by getting to the specific hash of it, and then you could recover it back from it. Now let us look at what is getDef. So getDef is very powerful tool. It helps you to show what's the difference between your code, between your commits, your branches, or all those things. So here this is meme that showing what does getDef do. It's basically help you find or compare the changes between your commits, your branches, your working directory. So now let us look how does this looks onto the coding area. So we first check how many commits do we have. We have 2 commits. Okay, so let's create called getDef command and see what changes have been implemented. So here let us copy this commit hash and we copy this, which was recovered from our previous lecture, and then so here we could see that this new line was not in the previous one commit, and this new line was added and in the new line file. So this are the this is the we could compare the changes between the readme file. So in a lot of big code changes, this could be in bigger way that you could see. Now let us see what is cherry pick commit does. Now let us look at what is cherry pick commit is. So suppose here is our branch, here is our commits, commit 1, commit 2, commit 3, and here is our feature branch 1, feature 1 branch, and here the feature 2 branch. Now we need this commit to be in this feature 2 branch. So how we could do this? So we need to use cherry pick command. So what does it basically does is it goes to commit hash, pick this commit code and paste this commit code here. So now let us look out how does this look. So first we add new line. This is third line we added, and we commit this new line added, line 3. Short, sweet and descriptive commit. Those changes will be directly committed and staged. Now it's have been committed. Now we switch to the master branch. Here we are on the master branch, and we need to commit cherry pick that latest commit from the feature that is our feature branch to the master branch. So we get log. We know we first switch our branch to the feature branch. Feature branch. Let me increase those, and we first clear our console. Get log. We get the latest commit hash. Pick those commit. I've copied it. Now let us go to the new console and switch our branch to master. Only one, that is git switch master. We are now on the branch master, and now cherry pick the commit from that branch. Cherry pick the commit hash we have provided, and here there is basically a code conflict. So see here it's saying that new line added and the commit the incoming changes, and this was our previous changes. So we accept the incoming changes and the conflict have been resolved. Now let us look how does this look in GitHub desktop. Hey everyone, in this section we are going to look at how you could do the same changes like git stash, git cherry pick commit, git resolve commits and directly onto the GitHub desktop. You can't do the git reflog things on the GitHub desktop because it doesn't provide that feature. So for git reflog you need a git bash. So first now let's look how you could do git stash in this GitHub desktop. So first we added a commit and we haven't staged those commits. So this is line commit 3. Now here in the repository we could see that we have added those changes. Let's switch branch, and before switching out the branch, the console is asking please stash your changes. So while moving on to the next branch, so we will stash our changes, or it is asking bring those changes directly to the feature branch. We will stash those changes onto the main branch. Once we come back to main branch, we could add those changes. So here we will add one more change, and then we will see how does the git conflict work. So we are adding one more changes so that we could create some conflicts between main branch and feature branch. So some line would be removed from the main branch while or the commit is coming. So we have added those changes. Here you could see. Now we have seen how does the git stash work. Now it's time to look at the git cherry pick. So to cherry pick a commit, we just need to go to the branch that we want to cherry pick the commit from. Then in the history, we pick up the commit and then go to the branch that we need to cherry pick the commit about. So here we pick top commit, head 1 commit, and then we just cherry pick this commit to the main branch. And here we could see there is a code conflict have been created. So we accept the incoming changes, or based on this, you could create whatever the conflict resolve that you need to do, either remove both line or either reject the incoming changes. With this, we have learned that how does git reflog, git stash, git commit, git branching methodologies work in Git. In the next lecture, we are going to look at an overview of the GitHub. So with this, thank you everyone for watching this lecture.